In question 9, we're given that there are n students taken on a field trip, and these students are split into two groups. In the first group, there have to be exactly 3 students, and in the second group, there have to be at least 3 students. We're given that in the first group, the students are randomly assigned, and in the second group, the remaining others are chosen into it. And we're asked to give an expression for the students chosen into the groups. So since there are n students going, and the 3 students are randomly assigned, we know there's going to be n something 3. But to determine whether it's combinations or permutations, so whether it's nc or np3, the order will not matter. You can have 3 students, as in A, student B, student C, or you can have student B, student C, student B, student A, or you can have student B, A, C, and so on 6 times, or 3 more times. It's not going to make a difference on how they're assigned, so it's going to be combinations. So for part A, our answer is simply just going to be n choose 3 or nc3. So for question 9 part B, we're given that 2 students do not want to work in the same group together, and consequently the number of students is halved. Since this expression n choose 3 tells us the number of ways we can assign our n students, and we're given that these students are now halved due to this, this is going to be n choose 3 over 2. So I'll write that. And in the question, we're asked to determine the value of n. We can't really determine the value of n from this, so we know that this therefore must be equal to something, and from then on we can solve for n. So we are also given that 2 students don't want to work in the same group together. So if 2 students aren't working in the same group, instead of having n students to choose from, we're going to have n minus 2 students to choose from. So we know we're going to have n minus 2 choose something. And we also know that they don't want to work in the same group. There are 2 groups, so if I just label the first group as group 1, group 2, and I draw a nice diagram, the first group only has 3 students, the second group has at least 3, so it's going to be a bit larger. And once again, I'll draw that. Our 2 students, if I label them as A and B, we can either have student A here, student B here, or student B here and student A here. So that means that there's 2 ways of ordering our students from group 1 and group 2. So that means we're going to have 2 factorial ways of ordering them. So it'll be 2 factorial times our n minus 2 choose something. Now for our something, we know that we are choosing 2 students who don't want to work in the same group together. So we're choosing n minus 2 from 2. So this is going to be 2. So we have 2 times n minus 2 choose 2 must equal to this. So this is equal to 2 n minus 2 choose 2. Multiplying by 2, I get that n choose 3 is equal to 4 n minus 2 choose 2. N choose 3 is n factorial times n minus 1. I'll write it down. N times n minus 1 times n minus 2 times n minus 3 factorial over this number factorial. So 3 factorial times this minus this whole thing factorial. So n minus 3 factorial. These 2 cancel out nicely. And that is equal to 4 multiplied by n minus 2 choose 2. So it's going to be n minus 2 factorial over 2 factorial multiplied by n minus 2 factorial, which is n minus 4 factorial. N minus 4 factorial. N minus 2 is n minus 2 factorial is n minus 2 times n minus 3 times n minus 4. So I can say that n times n minus 1 times n minus 2 over 6 is equal to 4 times n minus 2 times n minus 3 times n minus 4 factorial. They cancel out. So that's equal to n minus 2 times n minus 3 over 2. Multiplying by 6, 6 over 2 is, multiplying by 6, 24, 24 over 2 is 12. And these will also cancel out. So I get that n squared minus n must equal to 12 times n minus 3 must be equal to 12n minus 36. Minusing 12n, I get that n squared minus 13n plus 36 must be equal to 0. So now we want 2 numbers that add together to get minus 13 and multiply to get positive 36. So if I just write 36 here, we can have 1 and 36, which doesn't, 2 and 18, which don't, 3 and 12, don't, 4 and 9, 4 plus 9 adds to positive 13, and 4 so we're going to have...
From here the recording cut out, but basically we factor n squared minus 13n plus 36 equals 0 into n minus 4 times n minus 9. We know that n minus 4 cannot be a solution because we have to have 3 people in the first group and at least 3 in the second group. That means we have to have a minimum of 6 people, so therefore the only solution is n equals 9.